Hello bachcho, let's read the question. So the question says a police car with a siren of frequency 8 kHz is moving with a uniform velocity 36 km per hour towards a tall building which reflects the sound waves. The speed of sound in air is 320 meter per second. The frequency of siren heard by the car driver is. So we have to find the frequency of siren that is heard by the car driver. So this question is based on the Doppler effect. Okay. So according to which the apparent frequency is given by, that is nu prime, is given by nu naught C minus V naught divided by C minus Vs. So here let me introduce to the quantities. C is the speed of sound, V naught is the velocity of observer, and Vs is the velocity of source. So we can do this question in the two parts. In the first part, let us assume this police car is the source. Let this be the police car and this is the source of the sound waves, and this is the tall building, and from where it someone is observing, or this is the observer. Okay, so this police car is approaching towards the tall building with the velocity of 36 kilometer per hour. Okay, so this is approaching towards this tall building. So we can say nu prime that is equal to nu naught C minus, this is the velocity of observer V naught. Here velocity of observer is 0 because it is stationary. Tall building is stationary, so the velocity of observer is 0. Okay, so we can leave it as it is C, and in the divide C minus Vs as it is. Let this be our first equation. So this is our first part, and in the second part I am assuming after the sound wave is reflects from this tall building. Now this is the source because it is reflecting the sound wave. Okay, so now this is the source, and the man who is sitting in the police car, he is the observer. Now the scenario has changed. This tall building is the source of the sound waves, and the police who is sitting in the siren car, that is observer. So according to the Doppler effect, uh, this frequency is given by nu double prime that is equal to nu prime into C minus velocity of observer. Here the velocity of observer is negative because now it is going in the opposite direction. Okay, so this is negative of V naught divided by C. Why? Because here the source is stationary. Observer is moving. Observer is a police car that is a moving, and source is a stationary. So Vs is 0. Or we can write it as nu prime or C plus V naught divided by C. Let this be the second equation. So now I'm substituting the value of new prime from first equation in the second equation. So our new double prime becomes nu naught C divided by C minus Vs, that is velocity of source, into C plus V naught divided by C. Okay, or we can say nu double prime is equal to nu naught into, as these quantities will be cancelled out, C with C. Okay, this C with C will cancelled out. We will remain with only C plus V naught divided by C minus Vs. Okay, so this is our final formula. Now we will substitute the values. So nu prime, here the value of V naught. What is V naught? V naught is equal to Vs, that is equal to Vs, V naught is equal to Vs, that is equal to 36 kilometer per hour, or we can say if I'm changing it into minutes, then I'll only remain with 10. 10 minute, 10 meter. Okay, so and velocity v double prime, that will equal to 8 kilohertz now, or I can say 8000 hertz. So now I'm substituting these values into this equation R. Okay, so V naught is V naught 8000, and the speed of sound in air, that is given as 320 320 plus 10 and 320 minus 10. Okay, so by solving this, I'll get the answer 8.5 kilohertz. Okay, so our final velocity is this, and according to this, option A is correct. Option A is the correct answer. Hope so you have understood it well. All the best.